again. So this is what we have discussed last time. Transmission line input impedance. So we have known that different lengths of transmission line, different electrical lengths of transmission line also has different input impedances. Okay? And dili lang pag yun purely resistive na input impedance, no? But it could either be seen as a capacitor or a resistor or an open line or a short circuit. Okay. So last time, medyo nagduwa-duwa pa ko ani gamay, pero sakto dahil no, nalibog lang siguro ko sa akong own nga drawing. Pero correct na siya. Correct na atong notes nga nabuhat sa una. So I think from now, we'll focus lang pa more sa mga terminated at short. Okay? Terminated at short circuit. Why? Because as what I have said, really ideal na when we, let's say for example, we will match a line to a load, it's not ideal to use terminated at open lines because open lines might radiate electromagnetic energy. And ang purpose unta kay i-match ang line ug ang load, basig ang matching component is mag-radiate siya iyaha. So dili na siya ideal nga situation. Although in theory, pwede kita mo gamit og terminated at open or terminated at short na mga lines. So focus on sa mga terminated at short again. So kani and dire pareha lang ni siya kani og kani nga mga visual pareha lang, mas more generalized lang to sa previous nga page. So kani short, this one and this one. So kaning dotted na line, this represents an electrical length of lambda over 4, or 1/4 the wavelength. So any transmission line longer than this broken line, or kung mula pa siya sa broken line, meaning iyang length is between lambda over 4 and lambda over 2. Meaning this one, kaning last two na mga example sa bottom, ilang length sa ana is between lambda over 4 and lambda over 2. Okay? But then again, focus lang ta aning tulo, kaning terminated at short. This one, and this one. So, if our line is exactly lambda over 4 long, like this one, kaning pinaka-first na shorted line, iyang equivalent circuit is the parallel LC circuit. But we've known from circuits 2 nang iyang mag-cancel out lang mga reactances. That's why purely resistance ang mabilin. Hence, it is a purely resistive na line of maximum resistivity or maximum resistance. I mean, so kung may sa pitas nga kuan, solve siya. So again, this is input impedance, no? So it will be measured sa bearing perspective 1/4. So ang 1/4 long is from here lang to the shorted na part. Diba? Okay. So notice, the input impedance, if our line is just this long, kada naka-blue, no, is, diba? Maximum resistivity. Ang makita lugar sa measuring tool at this point is maximum resistance. So mo coincide, of course, ang kaning guide of this one. Second one, how about shorter than 1/4? Shorter than 1/4. Asa man makita dire. Diba? So this is an example of a shorter than 1/4 wavelength na transmission line. Kung saan input impedance, di ba? Inductance of decreasing value. The shorter the transmission line, the smaller the inductance. Nasa silong L, di ba? So, kung mag-lisod ta og basa ani, ano man dire meaning kung ang transmission line is less than 1/4 wavelength and terminated at short, it is inductive. And iyang reciprocal ana kung longer than 1/4 but less than 1/2. This is an example of a longer than 1/4 but less than 1/2. Is capacitive. And ma-observe man gyapon na dire. Longer than 1/4 but less than 1/2 is something like this. Diba? Capacitive. Diba? Capacitive iyahang input impedance. Yes, from left to right siya. From left to right. Okay, from left to right. Okay, magbasa man ka og input impedance sa left man na part, diba? Meaning, to logically follow na if ang atong piece of transmission line is a very short na terminated at a short circuit, no? Very short. Of course, it will logically follow na pinakagamay nga resistivity. Bakit short ba? So, kato lang, no? Ang endpoint ani is that we will know when our transmission line we will know when our transmission line we will know when a transmission line will be resistive or capacitive or inductive. Kada naman, no? Wala man na siya. Okay, so if that is, I hope that's clear. So we also mentioned one method to match a line and a load. If our line is, if our load is purely resistive, we will use this concept, the quarter wavelength transformer. This will only work for a purely resistive load, meaning ang atong load is wala reactance. Resistive load. Meaning ang atong i-insert in between the load and the line is an exactly 1/4 wavelength na piece of transmission line. And ang iyahang characteristic impedance, it could be obtained from this equation. But most of the time, this is not the case. No? More common occurrence is when mismatch occurs, load is a complex impedance. More giving common occurrence, load is complex impedance. When the load is purely inductive or purely capacitive, it absorbs no energy. So dili man po na siya possible unless gituyo na to o short or open ang atong load. That's when purely inductive or purely capacitive load happens. When the load is just a complex impedance, which is usually the case, it is necessary to remove the reactive component to match the line to the load. Okay. So if this is the case, the solution is to remove the reactive component. active component of load para ma-match ang line and ang load. So, sa kanyang situation, of course, we will not be using quarter wavelet transformer. Okay, kanasa lang ito magamit kung purely resistive. But this time, we'll be using stubs, no? Stub or the method of stub matching. A stub is just a piece of transmission line, no? Wala na iyahang kuan. That's what it is. A stub is a short piece of transmission line. Short in a length kind of way, dili ka ng naka-short or open. Short piece of transmission line. Transmission line stubs are commonly used for this purpose. A transmission line stub is simply a piece of additional transmission line that is placed across the primary line as close to the load as possible. Placed across the line as close to the load as possible. The susceptance of the stub is used to tune out the susceptance of the load. Now, what is susceptance? Have you heard of that term before? So, especially sa circuits 2. Susceptance. Actually, susceptance and reactance are the two sides of one coin, no? So, mo mas common na to nga gina-use, the impedance, okay, which is denoted by the letter Z, right? Ang impedance is a complex na variable. Na real component and imaginary component. Ang real component niya is ang resistance. That's why if walay reactance, resistance is synonymous to impedance. This is reactance, letter R, which is in ohms, plus reactance. Ang reciprocal sa impedance, denoted by the letter Y, is called admittance. Don't know kinsa na-assign ani sa una assign og mga names, no? Pero ato lang nang dawaton. Admittance. The reciprocal of resistance is conductance. And ang imaginary part sa admittance is the susceptance. So, motong susceptance. Mga reciprocal ni sila nga mga units, okay? Impedance, ang reciprocal is admittance, meaning Z is equal to 1 over Y. Okay. Resistance and conductance, reciprocal with each other, and reactance is susceptance. So when we say that the susceptance of the stub is used to tune out the susceptance of the load, it's as if saying the reactance of the stub is used to tune out the reactance of the load. No? With stub matching, either a short or open stub can be used, but shorted stubs are preferred because open stubs have a tendency to radiate, especially at higher frequencies. So, kana lang. So, if we have a transmission line, and mo na itong load. Para sa atong line na ay characteristic impedance, and impedance sa load. Where do we place our matching stub. So nakabutang across the line, meaning in parallel, as close to the load. So imagine lang nga, mag 3D na siya nga drawing. So natay duha ka variables here. And dili na din mo sulod si Smith chart na to. What are two variables? Actually, mga it begs the question ng mga answers ni ang ginapangita. How far should our matching stub be from the load? Diba? Ang nakabutang as close to the load, pero vague pa man na. How far man, how close, no? How close should our matching stub be from the load? So X, perhaps. And how long is this matching stub? So X is distance from load, and L is length of stub. Kanang ang mga questions ang ma-answer sa atong Smith chart. Kumani ang background behind using the Smith chart. Okay. Because matching stubs will be used to cancel out the susceptance or perhaps the reactance of our load. So sige, dato dire. Let's try to learn how this is used. Fair warning, medyo gini siya challenge, no? Mga ni-challenge even tong face-to-face pa, much more online. So, sige lang, dili naman siguro kita mo pabuhaton o ipa-plot o Smith chart because that would number one, it would need a Smith chart to begin with. Dapat at pagka-print, dapat di na madlag jump board. Dapat gid pagka-print sa Smith chart, ang mga numbers kay klaro, ano ba dili pixelated, no? That's one thing. Kinahanglan mo ruler, kinahanglan mo compass, no? Compass. Dagan kayo kuti kayo siya. Pwede rin siguro ninyo na i-self-learn kung ganahan mo, dagan mag-video sa YouTube nga talk about ani. Pero just for practice purposes, no? So di lang tamo i-require yun, no? Ato lang, again, our objective is to understand how stub matching works, no? Kung ano man ni isa man ni ka bond paper noon, mabitaw, no? Mabitaw dapat accurate yun kay gamay naman siya, naman siya bond paper. Diba? Ano example there, but bear with me na lang, no? So example, for a transmission line with a characteristic impedance of 300 ohms. So, kibalid, dili daw na to kuan ang transmission line. Then to insert. So for transmission line with characteristic impedance of 300 ohms, and a load with a complex impedance of ZL 450 plus J 600 ohms. Determine the SWR, the distance a shorted stub must be placed from the load to match the load to the line, and the length of the stub. So mo gito no, mo tong mga pangutanan katong akong introduce earlier. The SWR, distance of stub from load, and length of stub. Na, questions? Sige. First step. What's the first step? Sa nakadumdum. Divide. So usa to nga term yang gigamit. Usa to nga proper term. No, delete divide by 50. Given man ang kuan, normalized, that's good, no? Thank you. Mau. 300 ang given, no? So ang given is 300, so 450 divided by 300. So first is normalize. $1.5. So kung itong normalized load. So ano na makita? At first illocate si 1.5. Let's label this as si A and si B later pala. Dali. So si 1.5 is dili na siya sa horizontal line nato makita. Okay? Na siya somewhere dire. Okay, si 1.5. So sugod sa pinaka kinatumian, this is 0. Okay, mag-load sa kuan ay zoom. 0. And then as we move further to the left, to the right, this is the very center. When you see 1.0. 1.0 na 1.0 na matched line and load. So kung muna yung atong impedance nga plot, again, as what the previous video has stated, match atong line of load. So dili man, so dili diha. Ito 1.5. So diba? Si 1.5. Okay? So actually, okay, muna iyang impedance circle. Okay. Makoy compass, so bana na lang gid ni. Okay, right. Pag may pagamyon o create na kayo akong circle. So, muna yung impedance circle. 1.5 to siya. So, meaning ani, wala pa na ako i-plot ang J2. Wala pa. So, this is a Z of equal to 1.5 plus Jx, no? So this represents all, no? All complex impedances with a real resistance of 1.5. But then again, ang ato lang biyang impedance is just a dot, no? So it could lie anywhere on this circle. Pero I think na gets man ninyo na if inductive siya or positive, it will only be sa upper hemisphere. So wala na ni-appeal. No? So it will lie somewhere ani nga circle, semicircle. Okay. Whew. So far so good. Okay pa? So this is page 1 of 42 pages nga instruction. So kaya pa. Next, sa to? Upper nga semicircle kung positive. Pero kung negative to, ang sa ubos nga semicircle gapon. Ang J2 na. Sige. I hope, I think nakasabot-sabot na mo. Asa makita ang 2, no? 2. It lies sa circumference, no? Diha. So pangitaon na to diha ang pangitaon na to sa circumference ang 2. No? Positive 2. At least. Sa ako nga mag-load ang kuan. Na. So pangitaon na to diha ang 2. 2 sa circumference ha. So 1.0, 1.2, 1.4, 1.6, 1.8. Dala. This is 2.0. Kita na ang 2.0. So muna ang circumference sa atong Smith chart ha. Siya muna siya ang circumference sa Smith chart. Atong i-zoom out. So tungod kay muna ang 2, atong i-draw iyang curve. Diba? Extend lang na to padulong gid sa kuan. So far, so good. So intersection nila, mo to ang atong normalized impedance, which is this one right here. Muna atong Z of 2 plus J, so 1.5 plus J2. Okay, umana sa first step. Next. So si line C na siya. So asa ang SWR? SWR is masolve man di ba ang SWR? Pero makita na siya sa Smith chart. SWR. Kisay makasolve sa SWR ani before na to i-locate sa dili necessarily nga i-solve para ma-locate. Pero ato lang sa isolve daan para accurate ang atong pag-locate. So itong formula sa SWR. ZO over ZL or ZL over ZO. Okay, ma-solve ba? Complex pang doon. Hindi sila ma-solve ba? 1.5 maning 1.300 1.450 diba? So pinanglanggit siya i-flat. Uh-huh. 20. No, delete 20. Now karon nagamit ako ruler ha, ako yung ruler dire. Ako sa i-check na, that's why i-check. Dala. Medyo lisod ni siya gid guys, pero ang next step is gikan sa center, which is 1, right? So ning talungon ha. So ito i-measure ang distance gikan sa center padulong using a ruler, okay? I-measure natong distance gikan sa center padulong sa katong plot, intersection. Mga 8.2. Ignore lang ni 8.2. Kung ano yung sa akong ruler. So, gikan diha, mag-measure po ito sa horizontal line of same exact distance. Wala. Dili siya ma-solve. Kailangan dili siya i-drawing. So, nasa somewhere dire. And that is nasa mga 4.7. Nasa dito in between sa 4 and 4.0 and 5.0. Doon lang siya sa 5. So, nasa mga 4.7. So, SWR is equal to 4.7. It's supposed to be circle na siya. Supposed to be ano na siya, a circle. Kung ako'y compass, ganyan na nato na-locate ng 4.7 ng SWR. Pero hindi na siya accurate na circle lang. Medyo hiwi ganyan siya. Example lang na. So, gikan ni siya, ay kanang si term sa geometry, congruent. Congruent na sila. Press as like distance. Or press as like length of measure. Yes, parehas. Same length ang from 1 to intersection, which is Z. And ang kaning 1 to SWR, parehas. So that's the SWR. That's how to determine the SWR. 4.7. So, grabe ka mismatch, no? 4.7 SWR. Pagkakulo na siya. What's the next step? Rotate 180. Rotate 180 around the impedance circle to determine the normalized admittance. So, on 80 degrees opposite sa atong impedance is of course ang admittance. Ana, no? I hope accurate lang gini akong pag-drawing. Okay. So if this is a normalized Z, okay, kato na locate kanina. So wala lang sa inyong una tong SWR. So if this is a normalized Z, and we've learned here na we need to find the admittance to cancel out the impedance, the mismatch. So ato lang i-locate ang 180 degrees ane, no? 180 degrees sa other side, which is here. Same distance as before, this one. So it's here. Hawa na siya. Kung ato ning i-locate, this is nasa mga 0.24, 22, 24, 26, 28, 0.3. 0.24. Minus kani sa man eh. Sa mo ni siya ang kuan. Notice 0.3, 0.4. So 0.3, 0.32, 34, 36, 38, 0.4. So 0.32. So this is 0.32. So circumference, gapon na siya sa Smith chart na ito makita. So 0.24 minus J 0.32. Well, the same sa itong bought earlier, but inverse lang operation. 180 degrees away lang, same distance from Z. Sige, before I proceed, kaya pa? So that's Y, no? Ang Y mo na siya ang Y. So multiply lang ito na og 50, mo na dahil ang admittance, no? Pero hindi naman siguro need. So determine the distance from the load to the stub. Rotate clockwise around the outer scale beginning from until it's Impedance. Okay, next. Okay. Mubalik data sa atong R is equal to 1 circle. This one. Atong R equal to 1 circle. So next na nga atong pangitaon is what is the distance from the stub to the load? Ato daw pangitaon is ato ning extend further clockwise this one. Ay, same circle ni sila, di ba? Same circle ni sila. Same circle ba sila, ani? Equidistant man sila. Di ba? Klasa. Oh, dili man necessarily magsubay sa kuan. Sorry. Ang purpose lang day aning red line kay para mo locate nato. Allocate nato ning value. So dili man day na mo iyang circle. Tulaan ni gulay. Ano eh? Basta kay dapat makita na to ang iyang circle ani. So i-erase kay di na mo iyang circle. Ayan na bitaw. Ayan yun. Pakita natin yung circle. So, dili ni siya pan ha. Dili ni accurate pero muna natong next na step, no. I-drawing nato ang circle ni Z ug ni Y. So plus me na lang class na kung going tag-circle ani ni Z of ni Y, it will intersect the R is equal to 1 line at this point. So muna ang next nga step actually. Pangitaon, kung asa nag-intersect ang circle sa atong impedance, para mo din no? Admittance o impedance sa atong R is equal to 1 circle. Mag-intersect sila at this point. Assuming muna, I think ang yahang kuan. Yahang circle. So mag-intersect ang circle sa atong impedance ug sa R equal to 1 circle at this point right here. And this is 1, of course, plus J 1.7. Ito significance saan lang ako. The distance from Y to this point, ito i-term ano niya. R na lang, no? Distance, mo good ni. Distance, matching stub. Let's call this R na lang. So, the distance from Y to R, mo ang answer sa letter B, distance of stub from load. B is distance from Y to R, where R is the intersection of our impedance admittance circle. Usa lang to slag circle, di ba? Dy circle and R equal to 1 circle. Ang 1.7 is, di ba, ang first mo nato nakuha is ang intersection point mo actually. This one. So, kung ako ning ibalik sa horizontal line, of course, 1 na ito makuha. So, kung i-locate na ko ni siya sa inductance na kuan, dalang 1.7. Mag-the-same na niya sa pag-locate na to sa J2. Okay. So actually, wala pa na ito na-compute ang distance. Compute sa distance. Kung ato ni extend ang line here, and dito pod, okay, there. this distance to this distance, kana siya. Muna siya answers letter B, the distance of the stub to the load. Electrical distance na siya in terms of lambda na siya. So sige lang, no? Sakay kabalo lang ta. Saan pagbasa og Smith chart. Don't worry, di man ta mapasolve ani. Electrical distance is measured sa outer pagyud nga circumference sa Smith chart. No? So na siya i-measure kung dili na ta magtan-aw sa tablet. So that is where we should measure B, the distance of the stub from the load to the distance of the load to the stub. To determine the length of the shorted stub, calculate the distance from y is equal to infinity point, which is here, to point I. Okay. So sige lang, no? Ay, yun na ito na i-compute ng C-class. Kaya medyo complicated na gyud. Hindi na makaya sa atong powers. But at least ang very basic ani, I hope inyo lang nakuha. Asa i-locate ang real nga impedance, asa i-locate ang mga inductive capacitance, inductive nga reactance o capacitive nga reactance, how to locate the admittance, which is 180 degrees away lang from the impedance. So at least kato nga mga points, nakuha na ito ganina. Okay. Yellow, green na dot. Kanang 1 plus J 1.7. Kuan. Ang atong ZY or impedance admittance nga points, di man naka-form to siya og circle nil. Wala na ako, di lang ako ma-drawing dire sa tablet kay wala man tay compass. Pero kung ato ning kung natay compass, gikan sa 1.0, maka-form tag circle ni ZY. Big circle ba to? Ako tong guys kanina, basta kanina circle marag kana nga circle, no? Sorry, so kay drawing mo gud. Na. Basta supposed to be na circle ni si ZY. Okay? So ang yellow green na dot is intersection ni ZY circle ug ni R equal to 1 circle. Dala si R equal to 1 circle Dala, kaning yellow. Dala. Mana si R equal to 1 circle. So ang intersection sa R equal to 1 circle, ug intersection sa ZY circle supposed to be muna siya ang kani nga point. 1 plus J 1.7. Sige. Ako na lang ning i-upload appeal kaning mga kuris-kuris dire. kuan actually wala na siya tawag na point kay dili pa man ang ginamawon taon. Dili pa man ta ni ang atong main point why gilocate nato na siya nga point. Mao extend pa ni siya supposed to be padlong dito sa kuan, padulong sa outer nga circumference, and the distance from that point of the same here na moto ang moto ang distance sa matching stub from the load.
Sa yung gigot sir, nagrobot mo ka sir sa ako.
Okay. Kuan,
Stub.
ang kaning blue na line bitaw sa outer pagid nga circumference kana makita man sila dire even sa kaning nga view.
Oh yes sir.
Kanang pinakagawas gid nga blue nga circumference kan dako nga circle sa may circle. Kay mo na siya ang distance. Kung ato nang i-measure, mo na ang distance from the stub to the load. Mo na itong ginapangita gid ta. And dili ruler ang pag-measure ana. Bilangon lang man ang kaniyo, bilangon lang ni siya kaning mga numbers na dili pang minus, pang add lang na sila tanan. Na siya ang distance kay electrical length mo na. Yes, medyo nosebleed gid ni siya nga lesson. samot sa even sa una no, even sa una nga face to face may samot na siguro taban. Pero I'm glad to know nga at least sa mga sinugdanan nga part naka subay-subay ra mo. Okay? Labad yun. Kada na ipaktisan, no? Kung ganahan lang yun mo, pwede naman gini siya paktisan. Talang tayo actual nga. No, perhaps, no, sakto mo, perhaps nga dagang gig error sa una. Yet ila sigurong Smith chart kay dili siguro the same kadako sa kanang atong ginagamit lang nga bond paper lang. Kasi ilang Smith chart kay kanila paper gid kadako so ma-accurately plot la po ang mga points.
Kung face to face lugar sir, pagdala lugar bigyan mo ngani sir.
Prelims nila sa una.
Prelims.
Prelim ako ni sila sa prelim.
Pagdala mo nila paper?
Di man nila paper. Sa una, abinawag sa una nga face to face. Nasi ko slide print out daan ingani. Ang mga karaan nga RF engineers. Pero again before pa to sa age of computers. Ako pasabot nga sa una kay katong before face to face. Muna akong prelim sa ilaha kaninga activity. Dali ra gid ni class, dali ra ni siya. Isud lang illustrate dire kay na. Sige. It's 3 o'clock. Pansa ta. Break sa ta. Pawala sa 30 minutes be. Snack time.